Okay, so this is question 12, part B. The question asks, if the wire carrying conductor carries increasing I, what is the direction of induced current in this coil? So this is a wire and this is a coil. Both are conductors, which means that they can conduct current. Alright, so remember, when we have a straight wire like this, we will have magnetic field around it, right? Remember, using your right hand rule, point your thumb in the direction of I. Your fingers will show you the direction of the magnetic field. So if my current is like this, going upwards, my magnetic field is going anti-clockwise. We already discussed this yesterday, and I showed you how to draw the direction. So let's draw it like this first, and this goes out like that, right? Because it's anti-clockwise, it goes around, comes out of this coil or this loop. Okay, let me just correct that. Okay, and I told you that to minimize confusion, you can also say it is going into the page at this point and it is going out of the page at this point. Because it's going into the page, makes a circle like that, goes out of the page again. Okay, so the question is asking you, what is the direction of induced current? Right? Okay, so the important thing to remember here is that our I is increasing, right? Which means that our B is also increasing, which helps us to get this condition. What is this condition? This condition is required to get induced current. Okay, so we have increasing I, which means that our B is also increasing. It satisfies this condition, which means that we will get induced current in this guy. However, our induced guy will always oppose the change. Induced guy always, okay, this is my induced guys, always oppose change, which means that my guy will look like this. It says, oops, it says stop this change. That, okay, stop this change. No. So remember, induced current must always oppose change. So if my B is going upwards like this and it is increasing because my I is increasing, my B going out of the coil is also increasing. What will the induced guy want to do? It wants to oppose this increase. So it will want to go into the coil. Okay, remember, this is from our current, our wire. It is increasing out of the page. Induced guy does not like this. It says, stop changing. I want you to go back to how you were before. So it tries to make this guy stop increasing by going the opposite direction. So we know that if our induced magnetic field is this way, our direction is clockwise. So the direction of induced current in this guy is clockwise.